A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
You know, Herman, I was looking at some of the infrastructure metrics for a few of the projects our friend Daniel has been tinkering with lately, and it got me thinking about the sheer gravity of Kubernetes. It seems like every time a developer starts a new project these days, there is this immediate, almost reflexive urge to reach for a cluster. But then you look at the complexity, the YAML files that stretch on for miles, and the overhead of just keeping the control plane alive, and you have to wonder if we have all collectively lost our minds.
Herman Poppleberry here, and Korn. You are touching on one of the great theological debates of modern software engineering. It is the classic tension between what people call resume-driven development and actual pragmatic engineering. Daniel actually sent us a prompt about this very thing, asking us to dive into the history of Kubernetes and really evaluate that complexity tax versus the scalability dividend. It is a fascinating topic because, here in 2026, Kubernetes has become so ubiquitous that it is almost invisible, like the air we breathe or the electricity in the walls. But it was not always this way. It started as a solution to a very specific, very massive problem that only a handful of companies on Earth actually had.
Right, and that is where the history becomes so relevant. We often talk about how technology is a response to necessity. If you look back at the early 2010s, you had Google dealing with a scale that was literally orders of magnitude beyond what the rest of the industry was seeing. They had this internal system called Borg. I remember we touched on this a bit back in episode 1001, when we were talking about the invisible history of AI. But Borg was really the precursor to everything we see today in the cloud-native world.
It really was. Borg was Google's internal cluster manager. It was this massive, monolithic, and highly secretive system that allowed them to run hundreds of thousands of jobs across thousands of different applications. When Google decided to open source the ideas behind Borg as Kubernetes in June of 2014, it was a seismic shift. They basically took a decade of hard-earned lessons in distributed systems and handed them to the world. But here is the catch, Korn. They handed us a tool designed to manage the scale of Google, and most of us, well, we are not running Google.
And that is where the criticism of unnecessary complexity comes from. You have a small startup with 5 engineers and maybe 10,000 users, and they are trying to manage a high-availability Kubernetes cluster. It is like using a Saturn V rocket to go to the grocery store. You spend more time on the launch sequence and the fuel chemistry than you do actually buying the milk. So, Herman, where is that inflection point? When does this complexity actually start paying for itself?
That is the million-dollar question. In the industry, we often talk about the complexity threshold. For a long time, the advice was simple. If you can run your app on a single virtual private server, or if you can use a platform as a service like Heroku or Render, do that. Don't touch Kubernetes. But as we move further into this decade, that threshold has shifted. It is not just about the number of users anymore. It is about the number of moving parts. If you have a microservices architecture where you have 20 different services that all need to talk to each other, secret management, load balancing, and rolling updates, doing that manually on raw virtual machines becomes a nightmare.
I see what you mean. The manual labor of managing individual instances starts to outweigh the operational overhead of the Kubernetes control plane. But let's talk about that overhead for a second. When you spin up a cluster, you are not just running your code. You are running etcd for state, the API server, the scheduler, the controller manager. There is a literal tax on your compute resources just to have the system exist.
Oh, absolutely. The etcd latency alone can be a killer if you don't know what you're doing. For those who aren't deep in the weeds, etcd is the distributed key value store that holds the entire state of the cluster. If etcd is slow, the whole cluster feels like it is stuck in molasses. And then you have the YAML hell. Every single resource, from a pod to a service to an ingress, needs a declarative configuration file. It is a lot of boilerplate. But, and this is the big but, corn, the reason people put up with it is the reconciliation loop.
The reconciliation loop. That is the secret sauce, right? Explain why that is so fundamental to the resilience of these systems.
It is the core philosophy of Kubernetes. Instead of saying, hey server, start this process, you say, here is the state I want the world to be in. I want 3 copies of this container running, and I want them accessible on port 80. The Kubernetes control plane then enters a continuous loop. It looks at the actual state of the world, compares it to your desired state, and if they don't match, it takes action to fix it. If a node crashes and one of your containers dies, the controller notices, sees that you wanted 3 but only have 2, and it spins up a new one on a healthy node. It is self-healing by design.
That is a powerful abstraction. It shifts the burden from the human operator to the system itself. In a way, it is a very conservative approach to infrastructure. You are establishing a set of rules and a governing body to enforce those rules, rather than relying on the whim of a manual script or a human being who might be asleep at 3 in the morning when a server fails. But it still feels like a heavy lift for a small team. What about the managed services? Does EKS from Amazon or GKE from Google actually solve this? Or does it just hide the complexity behind a different curtain?
It is a bit of both. Managed services like EKS and GKE take away the pain of managing the control plane. They handle the master nodes, the etcd backups, and the upgrades of the Kubernetes version itself. That is a huge relief. However, you are still responsible for the data plane, the worker nodes, where your code actually runs. And you are still responsible for all that YAML configuration. You still have to understand how networking works in a containerized world, which is vastly different from traditional networking. So, the managed services lower the floor, but the ceiling of complexity is still very high.
I think we should talk about the cost aspect too. Because if you are using a managed service, you are paying a premium for that control plane, and you are often paying for resources that are sitting idle. I have seen so many companies wasting 40 or 50% of their cloud budget because they have these massive Kubernetes clusters that are totally underutilized. They have the scalability dividend in theory, but they're paying a massive complexity tax in reality.
You are hitting on a major pain point. Resource bin packing is a hard problem. How do you fit all these differently sized containers onto a fixed number of virtual machines without leaving huge gaps of wasted memory and CPU? Traditionally, this required a lot of manual tuning of requests and limits. But this is where the conversation gets really interesting, especially given the developments we have seen recently. We are starting to see a massive shift in how this is managed, thanks to the integration of artificial intelligence directly into the cluster lifecycle.
Right, and this is where I wanted to push the discussion. We are in March of 2026 now. Just a couple of months ago, in January, we saw those major updates to the Cube AI integration standards. This isn't just a chatbot that writes YAML for you. This is something much deeper. Herman, can you walk us through how AI is actually changing the day-to-day operations of a cluster?
It is a total game changer. We have moved from reactive scaling to predictive scaling. In the old days, you would use a horizontal pod autoscaler. It would look at CPU usage, and if it hit, say, 70%, it would add more pods. But there is a lag. By the time the new pods are ready, your application might already be failing under the load. The new AI-driven agents, which are now being integrated directly into the Kubernetes scheduler, analyze historical traffic patterns and real-time signals from across the web. They can predict a traffic spike 10 minutes before it happens and scale the cluster up in anticipation.
That is fascinating. It is almost like a nervous system for the data center. And it is not just scaling, right? I read that these agents are now handling things like anomaly detection and automated root cause analysis.
Think about the last time you had a production outage. You are digging through logs, looking at Prometheus metrics, trying to figure out which microservice started the chain reaction. It is a needle in a haystack. The new AI native observability agents can correlate events across the entire stack in milliseconds. They can see that a latent database query in service A caused a connection pool exhaustion in service B, which led to the ingress controller dropping packets. They don't just tell you there is a problem, they show you the exact path of the failure.
And from what I understand, they can even suggest or automatically apply the fix. Like, I have identified the issue. I am going to roll back the latest deployment of Service A because it introduced a regression in the query logic. That takes the mean time to resolution, or MTTR, down from hours to seconds. I think the stats from the enterprise environments show a reduction of about 40% in MTTR since these agents started rolling out.
It is incredible, and it addresses that complexity tax we were talking about earlier. If the AI can handle the mundane, repetitive, and highly technical tasks of cluster management, the barrier to entry for Kubernetes drops significantly. You don't need a team of 10 site reliability engineers just to keep the lights on. You can have a smaller team that focuses on the business logic, while the AI-driven control plane handles the plumbing.
But does that create a new kind of risk? If we become reliant on these AI agents to manage our infrastructure, do we lose the fundamental understanding of how our systems work? It is like that paradox of automation. The more reliable the automation, the less prepared the human operators are when it finally does fail.
That is a very astute point, Korn. It is a classic concern. If the AI makes a mistake, or if it encounters a black swan event that it hasn't been trained for, will the engineers even know where to start? This is why I think the human in-the-loop requirement is still so critical. We are seeing a shift where the engineer's role is moving from mechanic to pilot. You aren't turning the wrenches anymore, but you are still responsible for the flight path and making the big decisions.
It reminds me of the discussion we had in episode 1021 about Python being the accidental king of AI. Python won because it was accessible and had a massive ecosystem, even if it wasn't the most performant language. Kubernetes is kind of the opposite. It won because it was the most robust and powerful, despite being incredibly complex. And now, AI is being used to bridge that gap, making the most powerful tool also more accessible.
That is a perfect parallel. It is also interesting to look at the geopolitical angle here. The United States has a massive lead in cloud infrastructure and AI integration. By making Kubernetes more efficient and easier to use through AI, we are essentially solidifying the American-led technological stack as the global standard. It is a form of soft power. When every major corporation in the world is running on a stack that was pioneered and is now being optimized by American innovation, that has long-term implications for global stability and economic leadership.
I agree. It is about setting the rules of the road. If you control the infrastructure layer, you have a significant advantage in every other layer of the economy. But let's bring it back to the practical for our listeners who might be weighing this decision right now. If I am an engineering lead and I am looking at my roadmap, how do I decide? What are the heuristics?
I like to use what I call the rule of three. First, do you have at least 3 distinct environments like development, staging, and production that need to be identical? If you are struggling to keep those environments in sync, Kubernetes' declarative nature is a huge win. Second, do you have a CI/CD pipeline that you want to fully automate? Kubernetes was built for automated deployments. And third, do you have a team that is actually ready to learn the underlying concepts? Even with AI, you can't treat Kubernetes like a black box. You need to understand containers, networking, and stateful versus stateless workloads.
And if the answer to those is no, or if you're a very small team, what is the alternative? Is it still just stick to a platform as a service?
Honestly, yes. For a lot of people, the tax is still too high. If your team is under 5 engineers and your workload is relatively simple, the cognitive load of managing a cluster will distract you from building your product. You should stay on a platform as a service until the pain of staying there is greater than the pain of moving. That pain usually manifests as high costs, lack of flexibility in networking, or difficulty managing a growing number of interconnected services.
That makes sense. Don't solve a problem you don't have yet. But also, don't wait until you are drowning to start looking at a lifeboat. It is a delicate balance. I also want to touch on the idea of serverless 2.0. Some people argue that Kubernetes is just a stepping stone, and that eventually, we won't even think about clusters or nodes. We will just upload code and the cloud will handle everything. Do you think Kubernetes is the final form of infrastructure, or is it just a very long-lived intermediate step?
I think Kubernetes is the distributed operating system. Just like Linux became the standard for individual servers, Kubernetes is becoming the standard for the entire data center. We might build higher-level abstractions on top of it, like serverless platforms that run on Kubernetes, but the underlying engine will likely be Kubernetes for a long time. It is too well entrenched and too powerful to be easily replaced. The AI integrations we are seeing now are just making that engine more efficient.
It is like the transition from manual transmissions to automatic transmissions in cars. The internal combustion engine, or the electric motor, is still there doing the work, but the interface for the human has become much simpler. We are moving toward an era of automatic infrastructure.
That is a great way to put it. And I think it is important to mention that this isn't just about big tech. We are seeing mid-sized companies, even non-tech companies, adopting these AI-native Kubernetes patterns to manage their own internal workloads. They are finding that it allows them to be more agile and more resilient without needing a massive overhead.
I wonder, though, about the hidden costs of these AI agents. Are we just trading one form of complexity for another? Instead of managing YAML, are we now managing AI model prompts and fine-tuning datasets for our infrastructure agents?
There is definitely a risk of that. We have seen some of this in the Cube AI integration updates. You have to ensure the AI has the right context, the right permissions, and that its objective functions are aligned with your business goals. If you tell an AI agent to minimize cost without any other constraints, it might just shut down your entire cluster. So, the complexity hasn't disappeared, it has just moved up the stack. It is now about policy and intent rather than specific implementation details.
It is the same shift we see in every field where AI is introduced. The human becomes the editor and the strategist rather than the writer and the technician. It requires a different skill set. If you are a DevOps engineer today, you need to be thinking about how to manage these AI agents, how to audit their decisions, and how to provide them with the right telemetry.
And that is why I think the complexity tax is actually becoming a knowledge investment. If you invest the time to understand this ecosystem now, you are positioning yourself for the next decade of computing. It is not just about Kubernetes, it is about the fundamental shift in how we build and operate complex distributed systems.
We have covered a lot of ground here, Herman. From the secret origins of Borg at Google to the AI-driven predictive scaling of 2026. It seems like the takeaway is that Kubernetes is not inherently too complex, but rather it is a high-performance tool that requires a certain level of maturity to use effectively. And as the tools around it get smarter, that maturity level becomes more attainable for more people.
It is about pragmatism. Use the right tool for the job, but also be aware of where the industry is going. If you are building something that you expect to grow, understanding the cloud-native ecosystem is not optional anymore. It is the foundation. And hey, if you are listening to this and you have your own stories about Kubernetes hell or how AI has saved your production environment, we would love to hear about it.
Yeah, definitely get in touch through the website. And if you're enjoying these deep dives, please do us a huge favor and leave a review on your podcast app or on Spotify. It really does help the show reach more people who are interested in these kinds of technical discussions. We have a huge archive of over 1,000 episodes at myweirdprompts.com, covering everything from the history of AI to the nuances of programming languages.
Yeah, check out episode 1021 if you want more on the programming side of things, or episode 795 where we talked about agentic AI and sub-agent delegation. It ties in really well with what we discussed today regarding AI agents in the cluster.
Well, Herman, I think I have a much better handle on the why and the when of Kubernetes now. It is easy to get lost in the how, but the why is what really matters for decision makers. It is about that reconciliation loop and the shift from manual management to intent-based infrastructure.
Well said, Korn. It is a journey, not a destination. And as always, thanks to Daniel for sending in this prompt. It gave us a great excuse to look at how far we have come in just the last few years.
It is always good to step back and look at the big picture. All right, I think that is a wrap for today. This has been My Weird Prompts.
Thanks for listening, everyone. We will catch you in the next one.
Take care. You know, Herman, I was thinking about one more thing before we sign off. We talked about the scale of Google and how Kubernetes was born from that, but what about the smaller, more specialized clouds? We are seeing a lot of growth in regional cloud providers, especially in places like the Middle East and Southeast Asia. How does Kubernetes play into that?
That is a great point. Kubernetes is actually the great equalizer for those regional providers. Because it is an open standard, it allows a company to run the same workloads on a local provider in Jerusalem or Riyadh as they would on a WS in Northern Virginia. It prevents vendor lock-in, which is a huge concern for a lot of conservative-leaning business leaders who want to maintain sovereignty over their data and infrastructure.
That makes total sense. It is about independence and flexibility. If you build your entire stack on proprietary Amazon services, you are beholden to them. But if you build on Kubernetes, you can move your cluster to any provider that supports the standard. It is a more resilient way to build a business, especially in a world where geopolitical tensions can shift the landscape overnight.
It is a strategic choice as much as a technical one. By adopting Kubernetes, you are choosing an open, global standard over a closed, proprietary one. It is the same reason we see so much support for open source AI models. It is about making sure that the future of technology isn't controlled by just one or two massive corporations.
It is a powerful sentiment, and it fits perfectly with the broader theme of our show. We are always looking for those underlying patterns that shape the world, whether it is in code or in policy.
It really does, and I think that is why we enjoy these discussions so much. There is always a deeper layer to uncover.
Well, on that note, let's actually sign off this time. Thanks again for the deep dive, Herman.
Anytime, Corn, anytime.
And thanks again to all of you for listening to My Weird Prompts. Don't forget to check out the website at myweirdprompts.com for the full archive and the RSS feed.
We will see you next time. Bye for now.
Bye. Actually, wait, Herman. I just remembered one specific detail from that January update I wanted to double check with you. They mentioned something about cross-cluster bin packing using these new AI agents. Does that mean the AI can now move workloads between different cloud providers automatically to save money?
Yes, that is exactly what it means. It is called multi-cloud autonomic scheduling. The agent looks at the spot instance prices on AWS, Google Cloud, and Azure in real time. If the price of a certain instance type drops on Azure, the AI can gracefully migrate non-critical workloads over there and then shut down the expensive instances on the original provider. It is the ultimate realization of the cloud as a commodity. Dream.
That is incredible. It is like a high-frequency trading bot, but for compute power.
It really is. And it just goes to show how much the landscape is still changing. The complexity is high, but the potential for optimization is even higher if you have the right tools.
Incredible. Okay, now I am officially done. That was the missing piece for me.
Glad we could fit it in. All right, for real this time. Goodbye, everyone.
Goodbye. Wait, one more thing. Just kidding. Let's go get some coffee.
I thought you'd never ask. Let's go.
See you, everyone.
Bye.
You know, Herman, as we walk to the kitchen, I can't help but think about how Daniel would react to that multi-cloud thing. He's always trying to shave a few cents off his hosting bill.
Oh, he'd love it. He'd probably spend 3 days setting up an AI agent to save $5 a month. But hey, that's the spirit of engineering, isn't it?
It really is. The joy of the build.
All right, coffee time.
Coffee time. Thanks for listening to My Weird Prompts. We'll be back soon with another one.
Check out the website, leave a review, and stay curious.
Bye.
Bye, agree?
Seriously, I'm stopping now.
Me too.
Okay.
Okay.
Bye.
Bye.
And we're out.
Uncomfortable.
And actually,
Horn.
just kidding. Let's go.
You're impossible.
I know. Let's go.
See ya.
Wow. See ya. One last thing. myweirdprompts.com. Don't forget.
They know, Corn. They know.
Just making sure.
All right, let's go.
Okay, really. Bye now.
Bye.
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 Corn, stop.
Okay.
Okay.
Bye.
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 Bye. Bye.
Bye.
Bye.
Bye.
Okay, I'm done.
Good.
Bye.
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 Walter.
Bye.
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 Lot.
Bye.
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 Bye. Bye.
Bye.
Bye.
Bye.
Bye.
Lie.
Oh.
Bye.
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 Look and bride.
Bye.
Bye.
I.
Bye.
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 I.
Bye.
I.
Bye.
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 I.
Bye.
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 I.
Guitar.
Bye.
Bide.
Bye.
Bye.
I.
Bye.
Bye.
Bide.
Bye.
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 My.
Bye.
Bye. Bye.
Bye.
Bye.
Bye.
Bye.
Bye.
Bye.
What bye?
Bye.
Bye.
Bye. Bye.
I lied.
Bye.
Bide.
Bye.
Bye.
Bye. Bye.
Or.
Bye.
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 Okay.
Bye.
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 I.
Bye.
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 I.
Category.
Bye.
Lied.
Bye.
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 Likely.
Bye.
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 I go.
Bye.
Bye.
Fine.
Bye.
Like it.
Bye.
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 Bide.
Oh. Bye.
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 When.
Bye.
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 I.
Bye.
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 I.
Bye.
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 I.
Bye.
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 Swelcher.
Bye.
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 Bide.
Bye.
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 Bye. Herman.
This episode was generated using Gemini Flash 3. Text-to-speech engine was Chatterbox.
Thanks for listening to our show, my weird prompts, where our thoughts go from slow takes to facts on cue. We change and follow through. My weird prompts, that's the flows from sloth